Hey everyone, I am Huzaifa Khan, Big Data Operations Engineer here at Cloudera. In this video, we are going to go over building an end-to-end data ingestion pipeline for this use case. Let's first quickly walk you through the working of the data flow, and then we dive into creating the NiFi pipeline right from scratch. So without further ado, let's get started. So the data flow starts with a process group, within which we have configured 10 flow file processor that creates different flow files. Now if you see, each of these processors are mapped out to one Impala exception label, configured with failure-specific CM API. For example, this generate flow file processor here refers to out-of-memory label and is configured with out-of-memory failure-specific CM API. All of these 10 generate flow file processors are brought together and connected to a funnel. So the two update attribute processors placed next in the series takes all the defined variables and attribute values, encodes and brings them together to form a working CM API URL. Back to the main canvas. So the control rate processor configured after the process group helps in controlling with the data flow. Let's say you have an environment which generates large volumes of Impala query failures. We recommend that you configure control rate when implementing this pipeline. Here, the execute stream command processor is simply running a curl command against the CM API URL that generates the Impala query failure data into JSON format. The next three JSON-related processors splits, transforms, and fetches the required critical query failure data from the JSON output and updates them into Kudu table using the put Kudu processor. Now, let's head over to creating and configuring each pieces of this NiFi data flow in detail in our next segment. Let's drag the process group onto the canvas. I'll name this process group as generate alerts. Click on add. Let's go inside the process group canvas. Here we will be configuring the 10 failure-focused generate flow file processors. Drag the processor onto the canvas. Search for generate flow file. Select and add. I will demonstrate on how to configure this flow file processor for one label so that you can re-replicate the same steps on the rest of the 9 flow file processors. Let's configure this processor for out of memory. I will name it as OOM. Head over to the properties section. Here we'll be adding 4 custom properties relating to CM API. That's from, to, request, and lastly label. The from and to property values will be retrieving the last 10 minutes query failure data, which is configured in milliseconds. I won't get into much details of the value expressions and have the property values noted in the article for reference. The request property refers to the CM API string. Let's head over to the CM UI and show you an example on how to fetch the API string for memory query failures. I'm in my CM UI in Impala query section. This is the query that I'll be using to fetch the out of memory related query failures. So let's click on search and export. Export leads to a new tab. So this is your out-of-memory API string. Make sure that you remove the from and to parameters from the URL and use this string as a value in your request property. So back to the NiFi pipeline, we have used the literal expression here to pass the CM URL as a string in the request property. Click on OK. The value for label will be OOM. Hit OK and apply. Let's schedule this processor to run every 10 minutes. So back to its configuration. I will set the scheduling strategy as cron and the run schedule to be every 10 minutes. Click on apply. So follow the same steps to configure the remaining 9 flow file processors before moving forward. Now that we have configured all the generate flow file processors for the 10 labels, let's connect them to a funnel. Drag the funnel icon here and connect all of them together. Next, we'll be placing two update attribute processors. So let's drag the processor icon into the canvas and search for update attribute. Select and add. I will copy and paste it again. So the first update attribute processor here is configured to convert the from into property values to a URL friendly version. So we'll do this by using the URL encode expression. Let's head to configure. I will name this as encode properties and add two custom properties from encode to encode. So the value would be from colon URL encode expression. I'll do the same thing for the other two encode property. Click on OK and apply. The second update attribute processor, it brings all the defined properties in the earlier steps together to form a working CM API string. So let's configure it. I will name this as URL. Head to the properties section and add a custom property called URL. Well, I'll be just pasting the value here and I will note it down in the article section for your reference. Click on OK, settings, and apply. Let's connect them together now. The output of the second attribute processor will be connected to an output port. So let's drag the output port icon on the canvas and name this as output. Click on add and connect. Back to our main pipeline canvas. So let's configure the control rate processor now. Drag processor and search for control rate. As stated before, this processor basically helps with controlling the data flow. So let's head into its configuration. We are setting the rate control criteria as flow file count. Maximum rate is 1 and time duration as 30 seconds. So this means only one flow file will pass through the processor every 30 seconds. Let's connect them. Next, we'll be placing the execute stream command processor. So drag processor and search for execute stream command. This processor executes the curl command against the CM API URL. So in the configuration setting, we'll pass the command path as curl, an argument value as URL, apply and connect. So this execute stream command processor basically generates the query failure data output in JSON format. Next, we'll be using the split and jolt transform processor to split and transform the JSON data. I have copied the JSON output here for ease of reference. So we'll be using the split JSON processor to split the queries object into single line object. So let's drag the processor, search for split, select the relationships, output stream and add. Since we only want to fetch this 8 query elements, if you see this data is inside the attributes object. So to fetch this required JSON content, we'll be using the jolt transform processor. So let's head over to processor and search for jolt. Head into its configuration. The jolt transform DSL will be selecting shift. The jolt specification I've already copied here for your ease of reference. So I'm just gonna paste it. OK and apply. I'm gonna connect this to. Next, I'll be placing one more jolt processor to add an object with label and update time keys to the JSON flow file output. So let's drag the processor and search for jolt. Add. Right-click configure. So the jolt transformation DSL, we'll be selecting it as default. And our jolt specification would look somewhat like this. I have already copied the jolt specification here for your reference. Selecting the relationships, apply, and connect. Lastly, we use the put kudu processor to update the JSON data into the kudu table. So let's head over to processor and search for put kudu. Add. Configuration. Mention the kudu master host names here. The table name. We'll select the record reader as JSON tree reader. OK and apply. Let's connect these two. Now that we have implemented the entire data ingestion pipeline, you can go ahead and start each of these processors. Let's move to our next implementation step for this use case, that is to connect the kudu table to a visualization tool.